How's it going to all my savages out there? My name is the Trading Savage, and today I'm going to be teaching you how to use DBT like a pro. Specifically, we're going to be integrating DBT with BigQuery. Now, before I get into the technical details, DBT stands for Data Build Tool, and it's a fantastic way to create data pipelines that are, run locally or run in the cloud, and they integrate very well with Google Cloud, AWS, and so forth. And two quick notes. So there's two types of materializations in DBT that I want to mention: a view and a table. So a view materialization is a saved SQL query. So when you materialize a model as a view, it doesn't store the data itself, but rather the SQL query that generates the data. And when the underlying data that it relies on is updated, then that view will be updated as well when you take a look at the model. Table materialization creates a physical table in your database, and the data is stored in this table. And when the underlying data is updated, then the table is not necessarily updated itself. So that's a quick note on the materializations before we get into the implementation. So if you're ready to use DBT like a pro, especially with Google Cloud, then let's get into it. So I'm going to make a new project called, say, DBT project. Conda environment 311, let's say DBT project as the name of the environment, and create. Okay, so I have my new Python project here, and what I'm going to do is install some prerequisite modules in my Conda environment. So I'm going to do pip install dbt core in terminal. I'm going to pip install dbt BigQuery. Now, in order to initialize the DBT project, you need to do dbt init in terminal. Enter a name for your project. DBT project. Which database would you like to use? So I have DBT BigQuery installed, so I'm just going to say database number 1, BigQuery. Desired authentication method option. So I'm going to do OAuth. It's asking for the Google Cloud project ID. I'm going to go to my Google Cloud and get the project ID. DBT demo 9223. Dataset. The name of your DBT dataset. Now, we don't have a dataset yet, so I'm going to need to create that. I'm going to go to BigQuery, and I'm going to do BigQuery Studio, enable the BigQuery API. Okay, so now we have DBT demo 9223. The BigQuery API has been initialized. I'm going to go over here and click Create Dataset. Dataset ID, DBT project. Multi-region, US, multiple regions. Create dataset. Now, the DBT project dataset has been created. So I'm going to write dbt underscore project here where it asks for the dataset. Threads, 1 or more. I'll just do 1 for now. Job execution timeout seconds. Let's do 60 for now. Desired location option 1, US. So it's saying run dbt debug to validate the connection. So this is great. So now we have our DBT project right here. And what this looks like, there's all of these subfolders now: analyses, macros, models, seeds, snapshots, and tests. The models, this is where all of the SQL models are going to live. So this, for me, this is usually the most important folder here. In the models folder, there's an example folder, and there's these two example DBT models. The schema file here is the way to conduct data tests on the SQL models and, for example, write out descriptions for documentation and any column names so that people can follow what you've done. I'm going to move one of these example SQL files into the models directory rather than example. And I'm going to name this Analyze Titanic. Okay, now let's say I have this Titanic CSV that I want to use in my data pipeline. In my DBT project, I have a model called Analyze Titanic, which is basically just this example, my first DBT model that I renamed, and we're going to edit this later. First, in order to create the data pipeline and do anything with the data, I'm going to upload this to a Google Cloud storage bucket and then create a table out of it in our data set. So going over to the storage bucket, in cloud storage, I'm going to create a bucket. DBT project is fine. Oh, 9/2/24. Public access will be prevented. That's great. So now we have our cloud storage bucket. What I'm going to do is upload the CSV here. I've located the CSV in my project, and it doesn't need to be in the project. It can be anywhere. Then you upload the CSV, and what we are going to do is create a table out of that in BigQuery. And click Create Table. Create Table from Google Cloud Storage and CSV format. Choose the CSV and name the table Titanic Beta. Schema, I'm going to say auto detect. This is a fairly small CSV, and so it should be easy to auto detect the schema. But if it's not, then you're going to need to manually write out the schema. And potentially, you're going to need to make every variable a string type at first. Then with the data pipeline, you can convert those to other data types. Okay, create table. Now the Titanic data table has been created. This is what that table looks like. Now we're going to manipulate this CSV or BigQuery table with our data pipeline. So first, the schema file in the models folder is very important. In the schema file, we are going to describe our sources. So in this case, this is where we're going to add our DBT project, which is the dataset name and the database, DBT demo 9223, which is this here, the project. And the schema is going to be DBT project, which is the same as the dataset name. and the table. So we're going to use our source table, Titanic underscore data, which is right here. That's from our source, from our cloud storage bucket. So now that we define the source, we can make our model. And best practice is to describe the models in the schema.yaml file. So let's make our model called Analyze Titanic. Description: exclude null ages, group by age, and calculate mean of the fair column. Okay, so the columns are going to be age and mean fair. Description of ages, data tests. So DBT enforces these data tests when you run the model. So age needs to be unique and needs to be not null, and I agree with those data tests. Description of mean fair is, let's say, mean of the fair column. Data tests must be not null, which I also agree with. So we've described this analyzed Titanic model, and it's following the best practices, which are, it needs to have a description and needs to have some documentation related to the columns, what they mean, and some data tests for best practices and for people to follow your work. So let's run this DBT model. First, I'm going to conda activate DBT project. Next, I'm going to set my working directory to DBT project of DBT project. So notice, in my Python projects folder, I have DBT project, and then DBT made this folder here, DBT project. So you need to set the working directory to this folder here. So I'm going to do CD and this file path. So now we've set the working directory to this. Conda environment is activated, and I'm going to grab the name of this model, Analyze Titanic. The function to run this is dbt run, and then 2 dashes model, and then name of the model. Now I want to take a look at this. What does this look like? So analyze Titanic, as you can see, age and mean fair. So it's grouped by the age and calculates the mean of the fair column, which is mean fair. Now what I want to do is just make another model based off of this model to show how the data pipeline really works and how it's built. So what I'm going to do is just sum up the age and sum up the mean fair column. However, I want to enforce some rules too. So my model is going to look like this. Config materialize table. So we're going to make a table instead of a view, and we're going to sum age as sum age, and sum mean fair column as sum mean fair from the Analyze Titanic table or model. And as you can see, there's a difference in how we refer to the tables and models. So in Analyze Titanic.SQL, we specifically referred to this as a source, Titanic data. And the source is what we specified in our schema.yaml file here. However, in some Analyze Titanic.SQL, we're using ref Analyze Titanic, the name of this model. So this is how we refer to a SQL model versus this is how we refer to just a source table in our schema.yaml file. So I'm doing, sum of age and sum of mean fair. And I'm going to add a new section to the schema.yaml file with this new table, or this new model, enforcing some of these data tests and adding some documentation. So this is going to be sum analyze Titanic, sum up both columns. And column name, sum age, and sum mean fair. Sum age, sum of age. We don't need any data tests for that. Let's just say that's non-null. And sum mean fair. It's going to be the other column in that table, and it's going to be the mean of the. It's going to be the sum of the mean of the fair column. Sum of the mean of the fair is fine. Data tests not null. So we've specified that this sum analyze Titanic table has these data tests. Now, I'm going to save this and run the sum analyze Titanic.sql file. DBT run model, sum analyze Titanic. And it's completed successfully. So if we take a look at the new model here, and I'm going to just refresh this whole page so that the models refresh, and I preview this table, and this is what it looks like. Sum of age, just the sum of the age column, and sum mean fair is just the sum of the mean fair column. And that's worked perfectly. So that's how, the data pipeline works. This is the start. This is the first model, and then this is the second model, all building off of each other in the data pipeline. Now, DBT has some really cool functionality with, showing the lineage of the models and so forth. So I'm going to show you how that works. I go back to our terminal here and I write dbt docs generate. Let's generate the DBT documentation. So it's built the catalog, and now I'm going to write dbt docs serve. And now it's showing me in localhost, my web browser, my DBT project and all the details. So if I go here, I can see the DBT source, Titanic data, look at all the data types for the columns. That's super helpful. Go to the models in the project, and I can see analyze Titanic, details, description, columns, reference by, sum analyze Titanic, data tests, very important, very, very intuitive and helpful. Sum analyze Titanic is also very helpful, sum of age and sum of mean fair are both floats. This is the beauty of writing the documentation, is it shows you the descriptions, for example, of different things. Data tests, not null. And the most powerful thing is you can see the lineage of all of these tables. If you go to the View Lineage Graph button, click on this, and this is our lineage graph of the whole project. So DBT is telling us first we use Titanic data, source file. Then the next part of the lineage is analyze Titanic. And then this is transformed into sum analyze Titanic. So this is the lineage of this table here, these two. And as you add tables, add models, remove models, this is going to change. It can get super complicated, but it's very, very helpful for understanding how a project works. And thank you guys so much for watching. If you found this video helpful, please drop a like. And if you have any questions or comments, feel free to drop a comment down below and I will respond. So thank you all, and I'll see you in the next one.